Good morning, student. Today we are going to see second exercise of chapter number 4, refraction through the plane surfaces. Now, first concept, we are going to study about prism, which is a transparent medium. Okay, a transparent medium bounded by 5 plane surfaces. 5 plane surfaces with triangular cross section. Right? Now we are going to take only a section of the prism like this. Actually, this prism is in this way. Okay, so here this is the first plane, this second plane, third plane, fourth plane, and base is the fifth plane. So I can say this as 1, this as second, this third, this as fourth, and this base as the 5. So we find that this is a transparent medium, okay, bounded by the 5 plane surfaces and having a triangular cross section. So we are, while studying this refraction through this prism, we are just taking this cross section of the prism and we allow the incident ray to fall on it, and we will study how the refraction at the 2 faces of the prism happens, plane of the prism happens, right? Now, the 2 refracting surfaces of the prism makes an angle. They are actually inclined to each other. So they make an angle of the prism, which can we say as A, right? So this is known as angle of prism. Angle of prism. What is it? The 2 surfaces of the prism are inclined like this, and because of that they are making an angle, and this angle is known as angle of prism. Now let's see how the refraction of the light ray happens when it incidents on the prism. Assume that ABC is the prism or cross section of the prism. A ray of light PQ falls on the first intercept of the prism, first interface of the prism AB. Now this ray of light passing from air and going to pass through the glass medium. So here we find that it gets refracted and toward the normal, because it is going from rare to denser medium, so bends toward the normal and traces a path, say QR. Now here this refracted ray QR again strike to the second face of the prism AC and suffers for a second time refraction. Here it is going from a denser medium, which is glass, to the rare medium, which is air. So it bends away from the normal. We find over here actual path of the incident ray PQ, which incident at the face of prism AB, changes. Actually this ray, if prism is not there, then passes through this PQT path. This should pass, the incident ray PQ should pass through a path PQT, but due to the prism, the first intercept makes here a refraction, but it changes its path and turns toward the base, of the prism and passes along the path QR by deviation delta 1. Now, this is our incident ray, this is refracted ray, and RS is nothing but the emergent ray. If we backproduce this emergent ray, then we find that this QR again deviated by angle delta 2. And if we talk together about the deviation of a ray, incident ray PQ, it gets deviated by delta, angle delta. Now, this is the whole concept related to the refraction of the light which is incident and passing through the prism. So here once again see incident ray PQ, incident by an angle of incidence I, get refracted due to changing its medium from air to glass, and tracing its path QR get deviated by delta 1, or I can say refracted by angle R1. After that, this QR refracted ray which is seen here in the diagram parallel to the base of the prism, and second times it suffers for the refraction and emerges out of the face AC or through the glass prism to the air. So it bends away from the normal and deviated by angle delta 2. Here it makes an angle of emergence, say I2. Here I say I1. Okay. Now this PQ, which is the incident ray, suffers 2 times refraction, so it gets deviated twice, first by delta 1 and second by delta 2. If I talk a total deviation, then I can say the path of incident ray should be PQT, but it traces the path RS. If I backproduce, then I find here the deviation delta. Okay. Now let's see. Next one is how the relation between all these angles as well as this angle of prism. First of all, here we can see in triangle, I say here PQRST. Okay, so I see this as M, this as N. In a triangle QMR, this triangle, upper triangle, we find that delta is the exterior angle here, which is a sum of 2 exterior angles, sum of 2 interior angles, sorry, that is delta 1 and delta 2. So this is our first equation, and this we got by exterior angle theorem. Okay. Now second thing, here I get delta 1. Actually this angle I and this total R1 and delta 1 are opposite angle. Okay. So I can say here I1 is equal to R1 plus delta 1. Similarly, here I got I2 as R2 plus delta 2. So value of delta 1 by this equation I got I1 minus R1, and value for delta 2 I got I2 minus R2. Now first equation, putting this value into the first equation, delta gives us, delta 1 means I1 minus R1 plus delta 2 I2 minus R2. I get equation I1 plus I2 minus taking common R1 plus R2. So this equation is second. Okay. Now let's see in a triangle Q and R. Okay, Q and R, this angle. in triangle Q and R, I find angle Q and R as 180 minus R1 plus R2. Okay, Q and R is 180 minus R1 plus R2. So here I get, rather if I take this quadrilateral AQ and R, AQ and R, another way we can discuss this. In quadrilateral AQ and R, AQ and R, I find this angle N and this angle A is a supplementary one. Supplementary means I can say angle Q and R plus angle QAR is equal to 180 degree. Okay, angle Q and R I got is 180 minus angle of prism A. I say this as third. Okay. Now, in triangle Q and R, which we had seen before, पहले ही हमने इसको देखा था, अभी लिखते हैं. This angle Q and R is 180 minus R1 plus R2. 180 minus R1 plus R2. Already I have written this before writing this quadrilateral. I want to explain first quadrilateral and then this triangle. Okay. Now here I say this as 4. Both angles are same. So third and fourth implies us that 180 minus A is equal to 180 minus R1 plus R2. So here we get 180 get cancel. A is equal to R1 plus R2. I say this as fifth. A is equal to R1 plus R2. I say fifth. Now we can put this value of A, R1 plus R2 as a here in this second. So second and fifth implies us delta is equal to I1 plus I2, right? Minus R1 plus R2 as a. Okay. So I can say I1 plus I2 is equal to A plus delta or delta plus A. Means I can say angle of incidence plus angle of emergence is equal to deviation plus angle of prism. Okay, this derivation is not us, but still I give you more information about that. Okay, and next we are going to study about the factors affecting deviation. Okay, let's see factors affecting deviation. First factor, angle of incidence. Okay, I delta graph tells us that, means if we take I as on x-axis, delta on y-axis, then we find that for initial value of I, delta is more, and as the I increases, then delta decreases, and it decreases to its minimum value. So here I can say delta minimum. Okay, again further increase in angle of incidence, we find angle of deviation increases. Means here increase as I increases, delta also increases. This is first initially. At a specific value of I, okay, delta become minimum. Sorry, here delta decreases, delta become minimum, and further increase in I, we find delta increases. Okay, so these are the three steps you keep in mind. For increasing I, initial step in this section, you find this section, I increases, delta decreases. At this particular value, here we find at angle of I, delta is minimum, and again increase in I means this area, you find delta increases, and this delta decreases, and here delta is minimum, that I have already shown there, right? So in this way, the deviation depends on angle of incidence. Question is asked, state conditions for minimum delta, minimum deviation. This will happen only if I1 is I2 or R1 is R2. The second thing, refracted ray is parallel to base of prism. If these two conditions are fulfilled, then and only then we get delta as a minimum. Right? Now, next factor which we are going to study is about refractive index. Refractive index. Here we find angle of deviation increases if refractive index increases. So this statement tells us that delta for a violet color, delta increases as a refractive index increases. Third factor we are going to study about angle of prism. Angle of prism. As angle of prism A increases, then we find increase in delta. Okay. Next, fourth factor is lambda, which is nothing but a wavelength. Okay. Here we know that the wavelength for violet to red, if we see with here, then lambda increases toward R, V to R, right? There is increasing wavelength toward R, violet to red. Means I can say here deviation for the violet color is much more than deviation of red color. Okay. Also I can say refractive index of violet color is much more than refractive index of red color. By this discussion we can say deviation increases if lambda decreases. Right? Here we find more deviation for the violet and lesser deviation for the red color. So these are the factors on which this deviation depends. Okay. This exercise is over. Okay. In the next session we will see next exercise C. Thank you.